Okay, so the question tells us that an airplane is traveling south 35 degrees west with a ground speed of 270 kilometers per hour. So that's our resultant because it's ground speed. And it tells us that the nose of the plane is actually pointing south 22 degrees west with an airspeed of 262 kilometers per hour. So I've labeled that A. That's our vector right there. And then it wants us to find the velocity of the wind. So I connected the two here, and that's your wind speed. Wind is a component, resultant is the ground speed, obviously a resultant, so you connect them tip to tail and then draw your resultant. So to find the angle in here, you take 35 and subtract 22 and you get 13 degrees because of the angles at which your two vectors are leaving the north, south, east, west coordinates. So over here I just did a little legend. So R is our ground speed, A is our airspeed, and W is our wind. So to figure out the speed of the wind, you pretty much just do a simple cosine formula. So W squared equals R squared plus A squared minus 2 RA cos W. And you sub in all of your known values, and you get that W squared is approximately equal to 3,690.1232. So then you take the square root of that, and you get that the speed of the wind is approximately equal to 60.75 kilometers per hour. So then you need to find the direction of the wind. So again, you go to your cosine formula because you're trying to find the largest angle because it's across from the largest side. And you can't use sine law because you'll end up with an ambiguous case. So you could, but you'd have to solve for both. So it's much easier just to use the cosine law. So we sub again all of our values in. We start off with R squared equals W squared plus A squared minus 2WA cos R, because you're trying to find the angle of R essentially, which up here on our diagram. So it's the angle across from the resultant vector. So then you go back and you find that R is approximately equal to 91.2 degrees. Now we're not quite finished. To figure out the direction that's in, I remapped out our vectors, and you pop an X and Y coordinate down on there. And you know part of this angle here is 22 degrees because you use the Z pattern to figure that out. So then you need to figure out what that remaining theta is to figure out the direction. So you just take what you figured out for the angle of R or theta as 91.2. You subtract the 22 degrees from your Z pattern, and you get that the remaining angle is 69.02 degrees. And you can see from the diagram here that that is east 69.2 degrees south. So the wind's velocity is approximately 60.75 kilometers per hour in a direction of east 69.2 degrees south.